thank you all. So I'm a newcomer to this conference, so I might have over-engineered this answer, but anyway, I'm going to. I'm actually not an end user. I'm an infrastructure provider for Norwegian HPC infrastructure. So this is a quick overview on our infrastructure for high-performance computing, and it's centered around the 4 universities in Norway. And it's not clear from the figure, but the total installed base, including the system on Iceland, is approximately 1 petaflop. And that's substantially less than you have in the US, of course, even if you scale for the difference in population. But if you compare with the European PRAISE systems, they have approximately 15 petaflops installed base. So I think compared to the rest of Europe, we are quite on the right track. Well, my top issues actually on the HPC operations is first of all is organization. Using huge amounts of public money, it's very important that you define a clear purpose on actually what you're going to do with your equipment, and then make sure it happens with the best possible effort. In Norway, there has been estimates that there is between 3 and 5% of all public spending is pure waste. If you add procurement misbehaviors, it's even worse. So I don't want to be in that class. The other issue, which is becoming increasingly difficult, is the storage infrastructure, because of storage is so diverse, and also you want to couple storage and computing. And for instance, with storage, you also have this issue on research on medical data, which with very harsh regulations on what we're actually allowed to do. Well, new solutions. If you look at the top 500 list, the 98.7% of performance base is Linux, Unix. And traditionally, at our sites, just like most of your sites, I learned, is command line, right? But most newcomers to this infrastructure, and also from other sciences, are not very familiar with Linux, and neither with the command line. So there is a need to provide interfaces for using this at a higher level. And in that respect, we have been working quite some with bioportals, and we still have much work to do there. It's not very obvious on how to approach this in terms of effort in software provisioning and coding. The other issue, which is surprisingly always equally difficult, is the HPC training. Having 4 universities running 4 centers, it's very difficult to get one nationwide training program. And also nowadays there is a requirement that lectures are published on YouTube or similar. So to get videotaped lectures of high quality covering our needs is quite a challenge. Okay, a lot of this has been mentioned maybe already, but I had some different views maybe I said advance rather than revolutionize. So one issue which I'm observing, of course, like all of the others, is this the energy focus within the business, and also the performance increase we have seen in mobile computing and still are going to see. So I think this is promising with respect to new hardware and new systems. The other issue is the uptake of programming in the younger generation. The advent of new, very good and very fast, very cheap hardware, and also the efforts on doing programming for kids types of programs, which we have seen at least a lot of places, makes it very promising in that we will have a new generation which are much more familiar than programming and handling computers than we are. Also at the university level, I think there is a need to improve education in terms of using computing more tightly connected with lecturing the traditional sciences. And I put up one example there on what is going on. There is one effort at the University of Oslo called Computers in Science Education, where there is a tight integration between computing and education. It's very interesting, but it also has some difficulties in terms of teaching. Okay, so then I got a few minutes, and thank you. My end slide is actually from this area. Thank you.
Great, thank you very much.